We are now ready for our fifth and final section of Chapter 1 review. To start out with, we're going to talk about absolute value inequalities. When you have absolute value inequalities, they end up being compound inequalities. And when you get greater than or equal to symbols, that means that you're going to have an OR problem. And this is how I remember. Greater, I think greater. I know it's going to be an OR compound inequality. Less than, or equal to, that's really a different story. There's no special way to remember except that it's not greater. So less than is going to be an AND compound inequality. So to show you this, number 44 in your Chapter 1 review, which starts on page 64, that's a greater than or equal to inequality. So to start this problem out, it's going to be an OR. Notice there's an OR in between these two inequalities. The first way is you're going to write the x minus 5 is greater than or equal to 1. And notice I wrote that without any inequality symbols. Then we have the OR in the middle. Then we write the x minus 5. But now notice that I flipped the inequality symbol to a less than or equal to, and I made the 1 negative. You have to have both of those inequalities with an OR in the middle because it is a greater than or equal to absolute inequality. Now, what I'm going to do is I'm going to solve these, and I just have to solve them both. So I'm going to add 5 to both sides, which leaves me with x is greater than or equal to 6. Or, really important, add 5 to both sides, and I end up with x is less than or equal to positive 4. Now when I go to graph those, if I start with the 6, this is going to be a closed dot because there is an equal sign on that. And notice it's greater than or equal to, so that's going to go to the right. And then the 4 is also going to be a closed dot because there's an equal sign, and it's less than. OR problems always have arrows going in opposite directions. So that's how I would graph number 44. Number 45 is also a greater than inequality, so I'm going to skip that one because it's going to work just like number 44. Number 46. Notice this is a less than or equal to. There are two ways that you could do less than or equal to. First of all, you could do it exactly like we did the OR problem except put an AND in the middle. Notice it's 6z plus 5 is less than or equal to 25. I wrote it exactly the same without the absolute value symbols. And 6z plus 5, notice now I flipped the symbol to a greater than or equal to negative 25. The other way that you could write this, and this is the way that I like to do it, so this is the way I'm going to solve this problem, is you could write it as an in-between. Notice I put a negative 25 in the front. I kept a less than or equal to symbol, and then I have 6, notice I put an x, it should be a z, so it'd be 6z plus 5, and then you have the less than or equal to symbol with the positive 25. Now if I'm going to solve that, I'm just going to go ahead and subtract 5, and remember when it's an in-between, we have to subtract 5 from 3 places. So that gives me negative 30 is less than or equal to 6, and I'm going to change that back to a z. And then we have is less than or equal to positive 20. Now we divide everything by 6. So I end up with negative 5 is less than or equal to z is less than or equal to, and I'm going to reduce that to 10/3. So now when I write my number line, I'm going to go to negative 5. Again, this is a closed dot because there's an equal sign. And before I draw any arrows, let's think about 10/3. That's about 3 1/3. So I'm going to put my dot between 3 and 4, closer to 3, because it's about 3 1/3. And since this is an in-between problem, I'm going to draw a line between those two dots. And notice both dots were filled in because they're both equal to symbols. So that's how I would graph number 46. And now for the last problem in our Chapter 1 review, number 47. The circumference of a volleyball should be 26 inches with a tolerance of a ½ inch. Write and solve an absolute value inequality that describes the acceptable circumferences of a volleyball. Now for this one, I actually have to think backwards. If you work backwards, you know that because there's a tolerance of a ½ inch, x has to be between 25½ inches and 26½ inches. So I would write that as an in-between compound inequality. Then you think to yourself, what absolute value inequality would give you that answer? And again, I have to work this one backwards. The absolute value inequality would be the absolute value of x minus 26 is less than or equal to 1/2. And I know that because if I were to work this out, think back to the problems we just finished. I would rewrite this as negative 0.5 less than or equal to x minus 26 less than or equal to 0.5. Now if I add 26 to both sides, well actually all three sides, then I would end up with positive 25.5 is less than or equal to x is less than or equal to 26.5. So that means that this absolute value inequality is the one that works. And again, I had to work myself backwards in order to get that problem figured out. But that's how you would do number 47. And this now concludes our Chapter 1 review.